welcome everybody to the Global Passivhaus Showcase today. We're really excited to have Alex Boetzel and Laura Squillace from Green Hammer join us to present about the New Day School. Before we get to that part of the program, though, we're going to take a moment and go into breakout rooms to do some quick socializing. So this will be about a 5-minute session. So to use that time to do some rapid fire introductions, please. And I will set up these breakout rooms right now. And I'll see you in a few minutes. All right, I think we got everybody back. Hope that was fun. I'm about to introduce our wonderful guests, Alex and Laura, but before I do that, I want to throw it to Michael Ingui, who is founder of Passivhaus Accelerator and principal of Ingui. He's got a cool project going on, and he is going to just say a few words about that and share it with everyone. I think you'll be very interested to hear about it. So Michael, you want to take it away?
Yeah, thanks, Zach. How are you, everyone? A few of you already know about it because we published an article in it and we talked about it a little bit yesterday. But very similar to the way we've been aggregating information on the Passivhaus Accelerator and aggregating kind of really great conversations like the one we're about to have tonight. John Knapp, who's on here, and I are launching a company called Source 2050. And what it is a marketplace where it kind of completes that loop. So after people learn about what they can do and how they could do it, this is where you can buy everything in one place, compare it in one place, maybe get it delivered to your job site on time. The hope is that it can solve a number of the problems that we're dealing with, or at least I deal with often, in terms of just finding, getting, and having everything. And I think the goal is to basically lower that barrier of entry to new people coming in. So it's called Source 2050. John's here, so you can chat with him about it. He's the one who's running it. And if you've got questions or comments, or want to be the first one to kind of try it out once it's up and running, if you've got a product that you want to have on it, that information will be in the chat as well. So it'll be kind of exciting to be it's going to start to get built out and maybe launched for real, where you can actually see it in a month or two. It's kind of happening right now. So I know a lot of people have strong opinions about what something like this should include, what it doesn't need to be, what it definitely needs to be. So lay it on. Thanks.
Awesome. Thank you, Michael. So I get to introduce Alex and Laura now. And Alex and Laura are from a firm called Green Hammer, which is a design build company in Portland, Oregon. And I first was introduced to Green Hammer when I was a total newbie to this world about 12 years ago. And Green Hammer was a big competitor to the company that I worked with at the time, Hammer in Hand. And I was always jealous of the projects and the cool work that Green Hammer was doing. I feel very fortunate to now be good friends with Alex and meeting Laura, and I've really enjoyed to see the powerhouse of sustainable design and construction that Green Hammer has become. It's a real institution in Portland and beyond. So without further ado, let me dive into the bio for Alex. Alex is Director of Operations and Sustainability at Green Hammer with over, I have a lot of background noise here, I apologize. With over 25 years experience in construction and building science, Alex is a certified Passivhaus consultant and has consulted on dozens of LEED, Passivhaus, high performance, and green residential projects in the US as well as in Europe. He plans and executes Green Hammer's innovation concepts, technical training, including building envelope and HVAC, and ensures quality control of envelope, energy, and water systems in design, construction, and commissioning. Under his leadership, Green Hammer has consulted on over 200,000 square feet of commercial, multifamily, office, retail, academic, industrial, and single-family residential Passivhaus projects designed, built, or retrofitted in Oregon to date. Laura Squillace, architect at Green Hammer, earned her master's in architecture from the University of Oregon. She also studied environmental sciences and illustration, both of which strongly inform her work as a designer today. She's passionate about creating sustainable, beautiful buildings, and is inspired by her belief that it not only is possible to create buildings that give back to clients, community, and ecosystems more than they take, it's imperative. So with that, Alex and Laura, please take it away.
Hi, everyone. It's good to see you. Yes, as Zach wonderfully introduced me, I'm an architect at Green Hammer. And Alex, do you want to, hello?
Yeah, hey, I'm here. Yeah, thanks, Zach. That was really a great introduction. I have to say, like, I was so reminded of the early days when you did the tribute to Sam Hagerman at the FIAS conference, and just have to say, between we had those, we were competitors at the time, but I think it spurred us really to do what we're doing now and doing it well, and I think it was a great time to work alongside really in those days. Yeah, so like we've been in like Zach was saying, we've been in the industry like in high performance for like over 10 years now, and building Passivhaus since then. The one thing that's I guess we have to update. We have a living building under our belt now too. It's small, but it is fully certified, and we're really proud of it. So we really try to show what's possible and what can be done on any scale, and that's this is really a project that showcases that as well.
Yeah, I suppose it's also worth mentioning that we're among the 27 firms in the nation currently that are meeting that 2030 challenge, that we can go into in more depth later if people are interested in hearing more about that. But basically, we're on track to have all of our projects be carbon neutral by 2030, which means that right now we're reducing their operational energy emissions by 80% across the board. So let's jump in. Let's focus on the case study at hand today, which is the New Day School. This is a preschool in Southeast Portland, Oregon, along a bike boulevard. You'll see that there's a couple buildings here that are labeled as phase 1 and phase 2. Today, we're really going to focus on the phase 2 building that we did a deep green retrofit to. And then the phase 1 building that has the white roof with the skylights was a basic energy, lighting, and acoustic retrofit that we did beforehand. Built in 1960, that phase 2 building, no insulation in the walls or the roof, single pane windows, or a really old gas furnace that was not keeping it warm enough for the kiddos during the winter. And that non-insulative envelope was causing a lot of heat, unwanted heat gain in the summers. That was pretty unpleasant. In fact, they would have to close during the really hot days that are happening more and more out here on in the Northwest now. So in the end, what we were able to transform that building on the left with the solar panels into is essentially a net carbon or a net positive energy building, and making the campus actually like a zero energy campus when we all things are said and done. And so we'll dive into the specifics of this. But Alex, did you want to chime in on anything here?
I mean, so what's really important, I think the key piece here is two. One is it's a school, and we're going to talk about the benefits for schools, particular of high performance and associated ventilation and indoor air quality. And the other one is retrofits, which we're also talking about why it's important, but we have so many buildings, existing buildings, and I think we have like, the topic of embodied carbon, and this is one way to reduce carbon, embodied carbon when we retrofit buildings, which we have to do because we have so many anyways. So this is really what we want to focus on, is so like that's possible and what's possible to do with an existing building.
Mm-hmm. I want to just touch on what really inspired the client to embark on such a big and challenging project. We haven't yet met another or heard of another preschool in the nation that has achieved this zero energy benchmark. If you guys know of any other preschools that have, let me know, because then we'll stop saying that we're the only one. But they were really inspired to do so for a couple of reasons. One of which is that one of the directors built their own Passivhaus, designed and built it. And so they brought that to the table and got everybody on the directorship and staff level excited about kind of doing a project that used Passivhaus principles, was kind of where we landed, right? It's not certified Passivhaus. They also have subscribed to a philosophy called the Neo-Humanist Philosophy, which basically means that they extend the love that they have for humans to all beings, which dovetails very nicely with our thinking around sustainability and regenerative design, because they don't want to use or take more than they need to, and they really want to give back. So they were all for as sustainable of a building as possible. And then they also really saw the need to upgrade their building, especially for seismic reasons. They are part of neighborhood groups around resiliency, specifically in regards to the big earthquake that may happen in our lifetimes on the West Coast. And many of our buildings, including this one prior to the renovation, was not ready for a big earthquake. So that's what helped them come to us to make this project happen.
And so the goals that they really brought to us, again, safe and secure was important to them. Sustainable and resilient is what they're really kind of the last bullet point here says, the beacon of hope. Like they wanted to be this a special building that really kind of embodies the what they call here serenity and uplifting. So they really wanted to make this an educational space, particularly for the little ones, that that is healthy and that protects them and that's still inviting. So it's secure and inviting, you see all the light, but everything is open and transparent. And that's the goal that the goals that they came was to us. And so I think the next slide, we want to talk about how we transform that, those buildings.
Yeah, so as you all well know, figuring out how to conserve energy passively is what we first do, right? Before we figure out what kind of system we need to install to power it in a clean way on site. And so one of the ways we obviously did this was to really maximize that balanced daylight. The classrooms before we did our retrofit were single aspect. They only had glazing on one side of the classroom. So it was causing glare and poor daylighting. So they were having their lights on all the time. So we removed many of the interior walls except for the center of the structure, kept all the exterior walls, which we'll talk about later when we talk about embodied carbon, so that the classrooms could really have 2 and 3 sides of light, ample daylighting. And then the LED lighting that we installed adjusts to daylight levels. So the teacher doesn't have to remember to switch off the lights when they don't need the lights do that themselves. And then there are overhangs and interstitial spaces that really buffer the spaces from excessive heat gain and glare during the summer times. In conjunction with that, we obviously optimized the envelope insulation. So I don't think I mentioned, but the structure actually had kind of 4x4 post construction, and we kept those exterior walls. We didn't want to take down that structure and add our typical 2x8 construction because that would have a huge embodied carbon impact, right? So we kept the existing outside walls, filled in the cavity with recycled dense packed cellulose insulation, and then added that extra insulation on the outside. In this instance, it was 1.5 inches of wood fiber, specifically Gutex we really like to use. And again, that's a nice low embodied carbon material. So that got us at like an R26 and some change in the walls. And then we couple that with triple pane windows. We really love to use Zola. It's the best bang for the buck that we've found. We've tried many triple pane glazed windows and doors before, and we always end up back with Zola. They're a pleasure to work with and fun to install. And then the roof, similar to the walls, we filled in the existing cavity. We kept the framework of the roof framing. So got to an R80 by filling in the cavity with dense packed recycled cellulose, and then added 8 inches of EPS foam on top of that sheathing because we lose more heat from the roof than the walls. So we're really focusing the majority of our insulation on the roof. We did not take out the foundation so that we could insulate the foundation. Again, for carbon reasons, we kept the foundation as is. So working with the Lego pieces that we have. What we did do though is insulate the edge of that foundation, right? So the exposed 4, 5, 6 inches that we had, we made sure that that was insulated. What else we got?
Right, so the challenge in a retrofit, as many can imagine, is airtightness, right? So we opted, because we had existing structure, we opted to do an interior air barrier, and obviously the installation by the book is what we were able to do on the ceiling, which you see in the middle here, where you have a service cavity. You can see some wiring run, so like you really minimize penetrations, and areas for leakage. In the walls, we opted to not do a surface cavity, and we had very limited penetrations at that point. However, you can see, like, we did a smoke test that was, of course, the areas that were hardest to seal, In the end, we did get to one ACH 50. And we kind of had to share here our blower test results before and after. Like in the beginning, before the retrofit, we couldn't even pressurize the building. So we maxed out the door at 25 Pascal and roughly 6,000 CFM. And then at 50 Pascal in the end, we had like 626 CFM. So it's a success for us. And the only takeaway here is, surface cavity is really the way to go for an interior area. And then, like those are our envelope measures, and really what we really were interested in is to apply, like what kind of systems we could apply here. As we know, when we reduce the loads, we can now focus really primarily on ventilation, and that's what you see here in the upper left corner. Is a Ventacity HRV. So it's a commercial sized HRV that provides efficiencies that we're used to from like Zender and other, high performance HRVs. They're actually local to us, right, in Portland. And so we were able to use commercial sized HRV to provide ventilation for the entire building. It depends on who you're talking to for ratings. I think Passivhaus Institute says around in the lower 80s. HVI says like in the 90s in terms of efficiency, and you see in the center picture, a ducting that distributes that to the rooms. It's controlled by CO2, right? So the challenge is, particularly in schools, we have like a ton of occupancy if all the kids are in the classroom, and then very low occupancy, like if there's recess or after hours, and there still might be people in the building, administrative staff. And so CO2 is really how we control the airflow to maximize efficiency by still providing enough air, during the day. And then what's left is, as you can see again here in the middle, it's really residential sized heat pumps that heat the classroom. And they've been comfortable. Like you might have heard, like Pacific Northwest is a moderate climate, but we had, like incredible smoke events. We had an ice storm. People were out of power for 2 weeks, and the famous heat dome, 115 degrees, and they cruised right through all of those. So it's really a success in terms of comfort. We were talking earlier about the building being all electric, so it's also heat pump water heater. So it's an all electric building focusing on ventilation.
For you? Yeah, good.
So Alex will share some more specifics, even graphs in a moment, to really illustrate how much energy we were able to reduce, like the energy loads that we were able to reduce. But in general, we after all of our conservation measures, we only needed half the solar panels than we would have needed otherwise. And so it made the system much more easy to afford actually putting the solar panels up on the roof. The client decided actually though to max out the whole roof that you can see, so that the building itself is net positive energy. And then its extra energy that it produces goes back to the grid, gets credit for it at the same rate that they pay for the energy, and basically balances the books with the energy needs of the building to the right. So in essence, you could call the campus a zero energy campus. They have batteries on site, which allows the building to draw from the batteries when the PV is not able to generate power, which really helps, as you can imagine. And the big deal for the clients, obviously, is that they don't have an energy bill when everything is summed out. So better teacher salaries, more supplies, more resources for those kiddos.
Right, and so here's some graphs, like raw graphs. I have to admit that this is still model data as opposed to actual, which we're still analyzing. But essentially, we were able to reduce the UI by 50%, right? So from 25.7 to 12.9. But what the kicker is for us still is the peak demand, right? What we're talking about, because we're talking about zero energy, and saying like that's a big important message for us. All Greenhammer's buildings, all new construction buildings are currently zero energy, but we really want to explain to people that it's not just about PV, it's about efficiency first, and this matters, right, for the winter gap, right? If we able to produce a lot of energy in the summer, that's great, but if you have to pull it out of the grid in winter, then we're not really taking advantage of the carbon emission reductions that we could, because even in in the Pacific Northwest, where we have hydro, in peak demands, we're still firing up coal plants. So what's critical for us is to really reduce the peak demand in winter. And we were able to do that, right? So that was really a success for us. You can see like 80% in winter and 66% in summer. That's our reduction in the peak load. So we're really happy about those results. So again, the focus is on indoor air quality, the environment for the kids. And again, we've got 100% outside air that we're providing here. Which is, again, in the commercial setting, we're a small company. We do single family, small multifamily, some commercial. But as most people know who work in commercial, it's like providing 100% outside air is not very common yet, and it really has a huge impact, particularly on cognitive abilities. There's this famous study with Harvard. So here, really, the kids have the ability to take advantage of the 100% outside air. Light and materials. Laura, do you want to talk about the materials?
Yeah, sure. So if our indoor materials are off-gassing to any, measurable degree, then it's just an uphill battle, right? So we really focus on making sure that the materials that we put into these spaces, especially when we're talking about a preschool with little lungs, developing lungs, we're focusing on natural, non-toxic building materials. Wood, of course, wool carpets, linoleum floors. That main ingredient of linoleum floors, it's got like 3 ingredients in it really, but it's flax seeds, it's off-gassing, omega-3 fatty acids. If it was in any measurable quantity, it would actually be good for your health, but it's such a small amount that it's just negligible. We've already talked about natural light and views. We know that it's good for our bodies, our brains, our spirits to be connected to circadian rhythms, experiencing seasonal changes and weather and nature patterns, but that's especially true for kiddos. So we really focused on that in the renovation of this building. And then you'll see scattered throughout these images that you're seeing, like some biophilic design elements. I think designers oftentimes intuitively lean on biophilic design, but we really tried to be a little bit more intentional about it here, getting curvilinear elements in earth tones, plants indoors. That's just the kind of space that the school and its philosophy really values. So we worked with the client on developing those ideas. We have touched on embodied energy a bit throughout this whole presentation, and I know it's becoming more and more a center point of conversations as we're talking about carbon in general and how we can reduce it. So yeah, the main thing that we did is we reused as much of the structure as possible. We didn't start from scratch. That's like number one. And then the materials that we did add to the project, we were really conscientious about choosing ones that were low embodied carbon, right? We talked about the Gutex. We're really focusing on wood. We didn't take out the concrete. And then when we did deconstruct what we did, we worked with a wonderful company here in Portland, Oregon, that really deconstructs things very carefully so that everything could be reused. Everything that could be reused was reused. And then the insulation, right? Doing the dense pack recycled cellulose insulation has a really low embodied carbon impact. And we can go into more about this if people are interested to talk about this. We can. Yeah. Were you going to say something, Alex?
I just have to point out FSC, right? Forest Stewardship Council certified lumber. It's such a big one. We all talk about the benefits of wood and bio-based materials. And it's important that really the wood is grown and harvested sustainably. So we're, again, like Pacific Northwest, we're kind of the woods area of the country. And for us, it's particularly important because we walk in it, every day. But FSC certified wood really makes a big difference in terms of carbon and embodied carbon and carbon emissions, because if clear cuts, the forest floor combines so much carbon or binds so much carbon in the forest floor that all gets released. If it's clear cut, which is doesn't show up in any kind of like building accounting system for embodied carbon. It's a different calculation. And so it might not show up, and what looks great on paper, but if it's not FSC certified, it's not as good as it could be.
Yeah, I'm glad you mentioned that, Alex. We just have a couple more slides, and then we really want to open it up to questions and discussion. The client was well aware and interested in addressing some, but not all aspects of resiliency. They knew they wanted to be ready for the earthquake, right? So they did this seismic retrofit. We talked about that being one of the impetuses of this whole project. But what they didn't realize, and what they're extremely grateful for now, is that all the things that we did to make it a zero energy project really is helping them with resilience on so many levels, right? So they've got these batteries that help them through a number of outages and ice storms in the last couple of years. The insulation in that wall and the roof is really buffering them from the extreme weather events. Many schools have had to close during these really hot heat waves. They stayed open every day, and not to the parents' dismay, right? It's more comfortable at school for their kiddos than at home. The ventilation system that we can dive into in more detail if you guys want to has really helped with COVID. The parents, the teachers, the kids all just feel so much safer with 100% fresh outdoor air. And then they can turn off the ventilation from the outside when there is a wildfire event that has a lot of smoke in the air. And you know, they've been there for 40 years. They've got these amazing permaculture gardens. They've got rain gardens and water catchment, et cetera. That's all helping them feel more secure for a future that may have food insecurity and water scarcity becoming more and more prevalent and kind of at the forefront. So they're feeling like they really made the right choice, and it's paying off in dividends in so many other ways than they expected. We can also talk about financial support a little bit more later if you guys are interested, but basically they got the PV system completely paid for through the three things that you see listed on the slide: the PGE grant, Energy Trust incentives, which is specific to Oregon, and then parent contributions. They have a big alumni group, me included, that really was excited to support them in this endeavor and be part of the PV, making it happen. At this, we can open it up to a conversation.
Thanks, Laura. Just give us a second here. Thank you for that, Alex. Zach's just gonna show a slide.
Yeah, absolutely. Thanks. This is awesome. I'm gonna steal the slide for just a moment here.
Oh, yes.
And then we'll get back. We'll get back to you guys. Yep, I've got it. Oh, let's see. No, you're good. So I want to just take a moment and thank our sponsors. None of the work that we do would be happening without the support of all these organizations. And these are groups that share our mission to accelerate the transition to zero carbon building, and they're mission aligned and great organizations. So I hope that you'll consider supporting them in your work. Our founding sponsors are 475 High Performance Building Supply, Baxt Ingui Architects, Glavel Foam Glass Gravel, Minitaire All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, RDH Building Science, Rockwell North America, Stocorp, and Zola Windows. Our champion sponsors are Icon Windows and Doors and SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, AeroBarrier, BR+A Consulting Engineers, Brennan Airtightness and Insulation, Euroline Windows, Inotech Windows and Doors, Lamelux, Sanderson Sustainable Design, and US Engineered Wood, T-Stud. Thank you, sponsors.
Thanks, Zach. I'm going to dive into questions, and Scott Kennedy's got the first one. So over to you, Scott.
Boy, I just got back in time. I missed the tail end of the presentation, but anyways, my question really had to do with the unvented roof. And we struggle with this all the time. And I have consultants that just don't believe me all the time. Specifically building envelope consultants that say, put it all on top, don't want anything in the cavity. We've done 6 inches above and an insulated 2x10, and we've got monitors in there and everything's fine. But I was curious about how you're dealing with vapor control, condensation on the underside of the deck, and also particularly right at the end where you get the wall. I typically have shot a little bit of spray foam in that condition every time just to make sure I got vapor control. So that's the question.
All right, thanks. Like, where are you located?
Vancouver. Same climate as you guys.
Yeah, interesting.
Maybe
like,
a little wetter.
That's true. I mean, obviously, it's it's a pretty moderate climate, right? So really, what we do, the measures that we are considering is, for one, the exterior insulation to keep the roof deck warm. But then, as you've seen, we have a membrane on the interior, right? So we have a vapor control layer on the interior. In this case, it's a smart membrane, so it allows prevents moisture intrusion and allows drying. On top of that, we use cellulose. So cellulose has some, moisture storage potential. So as long as we're basically staying, even if we have to deal with some condensation on the roof deck, typically cellulose can absorb that and then, dry out to the inside. We did have certain assemblies where we also used sensors, to make sure, not this one, but others, where we make sure like our assembly perform. And we found that they do. And I guess other than that, I guess I go with Joe Strubick, who says like, just do what works. What it works, and it has so far. So that's where we're coming down.
Oh, that's good. So the red dotted line underneath the metal roof is, I assume that a metal roof? Is that what that is? Is that a metal roof?
Yeah.
Okay.
Yeah.
Is there a vented space there under the metal roof, or is that pretty much an air seal as well at that point?
So the dotted line,
I see almost two red dotted. I see a blue dotted line, a red dotted line. It almost looks like you've got a double air barrier. Is that kind of what's going on?
Well, the red line is our water control layer, right, on the outside, and then the blue line is our vapor control and air barrier on the interior.
Okay.
But yeah, the roof is not the roofing is not vented either. Yeah.
Okay.
Is that drainage mat.
Just for Sean's sake, is that Mento 1000?
Yeah, you see it in the picture.
I didn't see that. I wasn't even looking at that. But on the roof, did you use the Mento as well?
I don't know actually.
Okay.
I'm assuming. I assume so. Yeah.
Okay.
I believe we did.
All right. Thanks.
Thank you.
Scott.
That was the questions. Thanks.
Scott, I owe you a beer. Mark that on the tab that I have with you. Now we're going to go over to Australia with John. John.
Hi, thanks for the presentation. Great story, great project. The blue, was it HRV or ERV? I couldn't recall. Is outside the building envelope. Was there a reason for that? A space, or they work better outside over there? Can you tell me about that?
Say that again. Can you maybe rephrase the question? I'm not sure. I want to make sure I give you the right answer.
The HRV, I believe, was the blue box on the roof. And that's outside the thermal envelope, which is not the norm, as far as I know. So is there a reason for that, and how does it operate effectively? Right. So yeah, obviously it's preferable if you can have the HRV in the thermal envelope. This, I think, the origin of that originally came from the idea of the HRV replacing rooftop units. Right. So there's a program that they're really active in, replacing gas-fired rooftop units with HRVs and ductless mini splits. And it's really successful. I think that's where the focus came from on this HRV as a retrofit measure. They offer now other units as well. For us, it came in really handy because we already were like really space constrained. And I apologize about the background noise. I'm actually, as Scott was saying, I'm part of the commissioning team, and I'm actually on the project right now commissioning. I apologize, but yeah. So we had space constraints on the interior as well, so it worked really well for us to put it on the exterior. And like I said, we did some monitoring, and it performs excellent. There might be some loss, but it's a pretty efficient unit. And again, Pacific Northwest is a mild climate. We barely see any snow or frost if we don't have an ice storm. Thank you.
So yeah, John, just again, specific climate works for this particular unit, so definitely one to check out. So I see that Amanda had asked a question about the deconstruction team, which was Levitt Construction, and I agree with Zach again. The resilience piece you guys dove into is just a really interesting part of it. One question I had too is, again, the client already knew Passivhaus, so it wasn't like you had to turn this into a Passivhaus project, but you're able to get all the principles in there. You're even able to do a blower door, which is fantastic, and you've got a great score, and there's definitely some lessons learned there. So it's kind of like a little bit of like Passivhaus Fight Club, where you didn't have to talk about Passivhaus, you just got to do it. Was that something different for you guys to be able to just do what you do, but not have to talk about it?
Well, to be clear, we definitely talked about it. There were essentially 4 clients that made up the client team. Only one of them, who was essentially a retired teacher from there, really understood Passivhaus deeply. The other people understood it from a conceptual level and really from a heart level. But we were holding their hand and educating them the whole way because it's a collaborative process. We make all of the decisions with them. And because we're a design build, we're able to talk about cost at each step of the design process. So as we were making those big decisions about what do we keep, what do we chuck, what do we donate, what do we, etc., we were really educating them the whole way. And the person, Maitri, who really understood Passivhaus, stopped going to the meetings essentially when we dove into design. She was really there to kick it off and make sure that New Day really committed to what she really felt the school deserved and what she felt was the right thing to do for posterity's sake for this organization. We do that with all of our clients. Usually, almost always, clients come to Green Hammer because someone's already inspired or knows a little bit of, they've dug in, they're geeking out, but there's still so much education that we do, right, to bring them along. And they can't always do everything they want to do. So we help them do the cost benefit analysis, emphasis on cost.
But maybe, more specifically, because this is an interesting question, it is true that we don't have to talk about it as much as maybe, like Green Hammer has a reputation. People typically come to us and say like, hey, what do we need to do? And we're like, well, you need to do these things. And here's why. And it's really a shoo-in. When we talk about benefits, what's interesting to see though, is I would say 5-6 years ago, we had like the super green, like, hey, how efficient can we be? And now, like particularly with these changing climate, resiliency and independence really becomes the focus. So they come to us and say like, how am I comfortable? How am I, independent or resilient? And when we talk about energy efficiency, that sounds great. Throw that in too. There's definitely a shift in clientele, but yes, there's less need to talk about it because, like just the facts speak to what needs to be done now.
Yeah, and to be totally honest, we don't even talk about some of the things that many other companies really have to fight to get their clients to buy in on. Like triple pane windows are just already baked into the project cost. We make sure that all of our materials are red list free. We're just doing a lot in the background that they trust that's why they came to us in the first place. They kind of expect us to do that homework and they don't want us to ask them if they want it. But there's a lot that we do talk about.
Yeah, no, I'm sure. That's great stuff. All right, Peter had a question. Mr. P.H. Volnair.
Yeah, hello, great project. I was just wondering if there's any more room for more PV panels in the future on the other building, or do the skylights existing there preclude that option?
That's a great question. Let me touch on the skylights for a second, because that was actually the most exciting thing that we did to that first phase 1 light retrofit, which is that the skylights were there in the original building, but they had been covered up for decades by a tenant that was there, 50, 60 years ago. And so we got to re-expose them and bring in all this natural daylight, along with insulating it, the roof and the walls. So that was really exciting. I suppose you could put PV on that roof, but it's curved and the skylights, it probably wouldn't make much sense. But I think the big takeaway is they just don't need it. Especially if they can finish up the work that they're working on now, which is meter aggregation, so that they essentially don't have to pay the bill on the right-hand building, even though they're already getting credit for the left-hand building. They're just producing more than they need for the whole campus, essentially. So
there's one structural challenge, though. It's a bell vault, and they're basically notoriously under-designed. You could build nothing like that. You could build today. So if you touch it, you own it. So the upgrade we would have to do to it would probably prevent, from being feasible for PV. And like Laura was saying, we're covering 100% of the campus. That's more of a success than we anticipated. So I think everybody's happy right now.
I know, it's just great. As we'll talk maybe about more resilience in the after hour. I've got a couple more questions. Peter Reap, off to you.
Okay, thanks. Well, not a big issue in the big picture around energy efficiency and so on, but in my own experience, I've noticed how hard it is for folks sometimes to get used to tilt-turn windows. They swing open and they're heavy and they get in the way. Kids might bump into them, and if they're not operated properly, they get sort of hung up. So just did it take a lot of effort for you to tell teachers and so on, staff, to how these things work and how to operate them properly and use them for, getting the warm air out from the top and whatnot? Anyway.
Yeah, it's funny. I always expect more pushback than we get. Mostly people are overwhelmed by the quality that they experience when they hold it, move it, see it. They're just like, oh, this is nothing like a domestic window. It just feels as robust as I wanted.
Yeah.
Never dreamed a window could be. And yeah, I mean, everyone has their first couple of minutes trying to turn it and twist it to make sure it doesn't fall out, but it's a quick learning curve, I feel. Alex, you've been at Greenhammer far longer. What do you say?
Yeah, I mean, the benefit particularly here actually on a school is that you can actually tilt them, right? So you get cross ventilation and it's still safe and secure. And, so the kids don't operate the windows. They're typically in the vent position most of the time. So it's not as big of an issue as it might be for like a residential client who's like, hey, I want to open my window and, now it's sticking inside the room. It's, in addition to that, because of the ventilation we have, they're actually not prompted to open the windows much. So between the two of them, we didn't have any challenges talking to them about tilt-turn windows.
And again, it's nice that you're able to get the big window, so you're getting lots of light and less any bridges and stuff. So it's nice, this million. So.
Yeah, I mean, you can kind of see those are the 4x4 posts that were there, right? So that was the rhythm that we were working with, right? That determined our window pattern.
Yeah, just a lovely space. Thanks, Peter. We're gonna head over to Jeffrey.
So you mentioned that as you were going through the process, there was a lot of cost benefit analysis that was going on. And I'm wondering sort of what form that took. Was it sort of experience-based, where the conversations were at the level of well, we've done that, that's expensive, this is a cheaper way of doing it? Or did you actually go out and, cost it out, saying, go to a subcontractor and say, this is the design, in like a cost bid sort of mode? Or was it something in between where you kind of said, well, we sort of modeled it, and so I'm just curious as to how that works.
Both and, right? For questions that we get all the time, like, do we really need triple pane windows? Because that does come up. We talk through that and have a conversation in that client meeting right then and there, and don't go back and do a cost benefit analysis usually, but many other things, yeah, we go back and pencil it out, talk to the trade partners, the subcontractors, and come back to the drawing board the next week and present real numbers to them so that they can make an informed decision with us. Alex, I don't know if you can think of examples or if you want to just chime in about how you feel about that.
Right. So, I mean, to be honest, the original actually at Greenhammer became a design build company was to have more control around, that aspect as well. So we control the design and the execution, which means we do have experience. We have experience in like what goes into the building and what does it cost, right? So the cost benefit analysis is really around like, hey, how far do you want to go, right? And do you want to do Passivhaus? Do you want to do something similar, or what are your goals? And then in this particular case, again, we were trying to convey that how much energy efficiency is related to the well-being of the kids, which was really their big goal. And that's probably the biggest education you have to do is how are those two connected? And then in the end, what it comes down to is they have a budget that was fixed, like, hey, this is all we could raise. This is the money we have. How efficient can we get? Right. And so at that point, you're like, okay, is that trade-offs in terms of finishes or, some additional features where we can always come down to like, look, we're going to touch this envelope. This has not been touched for 60, 70 years. Right. And it's probably going to be 100 or 150 years until we touch the envelope again. Let's focus on that because interior can always change or more easily change. So that is probably more the kind of conversation that we have than that they say like, well, how much more comfortable am I with triple pane versus dual pane windows, because it's hard to quantify. So we really try to make this education how it works as a system. And then we say like essentially like, what's your budget? And we try to meet it, and here's how we could. And then when really the trade-offs is like essentially like amenities of the interior versus like performance of the building itself.
Yeah, Alex, you're reminding me that when we first started, and Maitri, the Passivhaus expert on their board, was present at the meetings. That was one of actually the first discussions that we had, right? Because she was 100% sure that it should be certified Passivhaus. And so was the entire board at that point, because all they had heard was, her side. And we were excited about that. But we quickly realized that there was a disconnect between what they could accomplish and their other goals. Namely, their budget was the restriction. We were looking at 2-story renovations. I mean, right, just like any project, we start big and then we narrow in very quickly.
So I just want one follow-up question, because very often a lot of decisions happen in schematic design that actually tie down your costs pretty quickly.
Mm-hmm.
And so how did you deal with that? I mean, I know it's a learning process, but as a design build, you have the experience under one house. In a lot of situations, you have, the general contractors not brought in until, more conceptual or even construction drawings are being done. So do you have any thoughts along those lines that you could share with us?
Yeah, I mean, the classic one is, yes, bring everybody at the table as early as possible. And that's the case. We're just like, okay, we just own the table, because then we're in control and can have everybody there. But essentially, it's very similar. Like, we treat the budget like an energy model, right? So we have a schematic budget. Like, right off the bat, we might even start with a budget and say like, okay, what do you want to do? Okay, this is what it's going to cost. And then every design decision, we make updates to the budget, just like you would to an energy model. So once we create basically our baseline, okay, this is our budget, this is where we want to be, any design decision is going to be immediately tested against the budget, so that we know we don't have a runaway budget. And because of the collaboration we have, our designers are well versed in construction cost and constructability, and our contractors, like our builders, and really understand design intent, right? So they can really provide feedback like, hey, I get what you want to do. Why don't we try this instead of that? We could make that much more affordable. So that's just the kind of conversation we have. And we always expressively call our clients like team members, because like, hey, we are a team, we need to work on this together. Otherwise we will not get to these goals. And having these open conversations with the clients, in front of the clients, like, hey, what's doable, what's not, really creates that trust that like, okay, we get it. Like, we don't experts, we see that you are, and we understand your solution finding process, and that you're going to be delivering us the best you can on the budget and the program that we're requiring. So those are really the key. Early, bringing in early, and then really have those conversations so that clients understand where the decision-making process comes from.
Fascinating. Thank you very much. Great project.
Thank you.
Thanks, Jeff. Great questions. Zach, over to you.
Great, thank you. Yeah, this is fantastic. So I have a few announcements to make before we throw it back to Sean. The first is that on the Passivhaus podcast, the current episode is an interview with Dr. Diana Urga-Vorsatz, who is the vice chair of Working Group 3 of the IPCC. So she is well positioned and a great thinker about the role that buildings can play in achieving climate goals outlined in the Paris Climate Accord. So please check out that interview. It's a really great one and perfectly timed for the COP26 conference that's about to start on Halloween. We also have a special component episode with Hugh Wierisky of Partel, where he talks about his background as a high performance building practitioner and engineer, and then transforming into a leader in manufacturing and creating high performance building products. So that I had a great conversation with him that I hope you'll enjoy. Tomorrow morning, we have the first episode of our new series. This is an 8-month, once-a-month mini-series called the Building Performance Interactive. This is a UK and Ireland-based series, and it will feature Tomas O'Leary talking about the training centers that are popping up around to make the NZEB, or nearly zero energy building regulations happen in the field. It's a really great tour of the centers, as well as a conversation with Tomas, with Hugh Wierisky of Partel, who's one of the co-hosts, with Mike Jacob of Kiss House, and with the podcast host of Passive of House Planning Help, Ben Adam Smith. Sorry. So please join us tomorrow morning. It's going to be early. It's 6 a.m. Pacific, 9 a.m. Eastern, 2 p.m. British summertime. And then on November 2nd, Michael and I will be doing a high-level Passivhaus primer for students that if you are new to Passivhaus, it'd be a great opportunity for you to get a crash course in the very, very basics of all of this. If you know students who would benefit from this or be interested in it, please share this information. I will put links in the chat in just a moment. And then next Tuesday on Construction Tech, we have a return of Ilka and Steve from Holstrom talking about SIM Part 2. And then Showcase, we have a very exciting project, the rising up from the ashes of one of the wildfires in the Santa Cruz Mountains. This is a project by B Public Prefab. It took 6 months from design to the construction on site of the thermal and structural envelope of this building. Really cool and inspiring work. Finally, on November 5th, we will be working with NAPHN, or I'm sorry, the Passivhaus Network. They've rebranded to Passivhaus, the Passivhaus Network, to do a virtual tour of Engine 16, the Baxtingwe Passivhaus retrofit of a historic firehouse, and kick off the International Passivhaus Days. There are going to be a whole bunch of open houses across the US and also virtual tours internationally. So we'll do the virtual tour live of the Engine 16 and then talk about the opportunities to see a bunch of other projects as well. That's it. Thanks.
So many great stuff. Hopefully everyone put that all in their calendar for another busy week next week. And hopefully you've got your coffee ready for tomorrow morning. I'm excited. I've set my alarm clock. I've checked it twice and might have put a bit of a buffer for snooze in there. I'm looking forward to it. It's going to be great. I love being able to go across the pond and seeing what's happening over there. Good stuff. Thank you, Zach, for that. That's great. We still have a few more questions for Laura and Alex, so hopefully we'll keep them as long as we can. I know Alex is working hard. I love the green screen because we're not seeing all the mayhem happening behind you. We hear it. I'm excited. I'd love to know more what's going on, but appreciate what's happening there. It is the top of the hour, so if you have to leave, we get it. We're glad you showed up for the first hour. If you want to stick around for the after hour, I will stay with you as long as I can until my dinner is made and I have to depart, or unless Alex and Laura need to head on to their own evening event. So I'll stick around. So thank you, everyone. We appreciate you coming. And if you're about to leave, remember, you have homework. You need to bring a friend. And as Jeff said earlier, next week, we hopefully will get to introduce your friend and tell us what they're about, how you hooked them to coming, so we can grow. And as we're trying to do, accelerate the movement of the Passivhaus Network. So thank you all for joining us. And we're going to head over to Mark, who had a question. So Mark Stauffer, over to you.
Thank you. No, I guess for some context, we are property owners that focus on preschools, and there's about a dozen, and there are existing buildings. And so I'm a architect and a Passivhaus consultant and Passivhaus builder, and for us, the grappling issue is cost. How to make this happen with at least here in Pennsylvania, where budgets are very tight for childcare centers, and so it's just, I'm curious to learn a little bit about how you all, with your client as well, were able to accomplish this. And did you find that this was incumbent upon subsidies, or were you able to do it sort of within the, let's say, budget what the client really had to work with without additional inputs of finance?
Great question, Mark. To my knowledge, the only thing that really got subsidies or grants and support from a governmental organization was the PV panels. Everything else was funded internally by the preschool. That said, this isn't a typical preschool. They're part of the Ananda Marga movement. So it's a larger organization that exists all over the globe. And there might be a money flow that I'm not really privy to understanding deeply that might have helped them financially. But from working with them extensively and being a parent of a child that went there, they are like many other preschools, maybe all other preschools, like they're just cash strapped. It's a really hard financial nut to crack. All projects have financial woes, but preschools are just, yeah, it's, even though you pay them a lot of money.
Yeah. So but I guess another, sorry to follow up, but
not at all.
They were able to sort of understand the sort of the difference between sort of the cost versus the operating cost, and if you can reduce their monthly operating nut, then
yes,
there's money to go back into.
Yes, that was one of the first
capital investments.
Yes, it was one of the first conversations and one of the last conversations, and then everything in between, right? When they're getting cold feet about something, but they really don't forget it. They know how much they fork out for operational energy. And they are also so mission driven too, that they weren't waffling on sustainability measures the way that many other clients might. If my numbers are correct, I think we were at a construction cost per square foot of $285. And without the PV and without design and permitting fees, I think it was at $700K. And it was a 7-month construction, Reno.
Yeah.
Maybe the other.
Sorry. So which were they able to remove, like, have another place to go?
That is a great question. That's actually my most exciting thing to talk about. Alex, did you want to say something before I get excited about this bit?
The only thing is, I don't know that that's typical for preschool, but they're a nonprofit. And yes, that was, for example, what helped them secure the grant. Now, that was a grant for from the utility for the PV, but that was a very competitive grant. And it, I'm not sure that as a private-owned business that would have been able to get that awarded. So there was some help there. There's probably some. I don't know if that's typical for preschools to be nonprofits, but there might be that. Exactly.
Yeah.
I mean, not that they do not make profit, but they actually officially have that status. Right? So,
yes.
Yeah. Mark, to your question, the reason I got excited was because that was my main worry. As a parent, I felt, and I was an alumni parent when we started design on this project, I was really concerned about what parents would think, what the teachers would think, the staff and the kids when there's construction dust, construction noise, disruption. So I could pull up the screen again, but I won't. There's a third building that I didn't talk about that actually is associated with the school. It's a house where some of the teachers live, because again, it's kind of a spiritual organization that runs it. So they kind of, anyway, there's housing associated with it too. So the kids actually, my child was in the house as a temporary classroom during construction. There was not a single complaint during the entire construction process. The kids were fascinated. We actually took the time to teach them about building science. And when they moved in, they cared so much more about the building, the staff and the kids as well, just because they saw it happen. They really understood what it took to make it, and that it could be that building is fun and that you can really make a huge difference through the built environment. So no complaints, only positive.
That's really cool to like turn it into a whole educational experience,
Yeah.
Thank you.
Yeah, thanks too.
Geez, like the win-wins just keep on going, right? Oh. I
can talk about the negatives too if you want.
No. Well, I mean, we all understand construction, that's not a no-brainer. But just the stuff you talked about tonight, the resiliency. I mean, that's kind of my big takeaway. It goes on and on of just what this building can do for that operation. And I mean, a lot of times we just talk about the Passivhaus stuff, but the fact that there's just layer after layer, and maybe we can just talk about the whole embodied carbon. I mean, last night we had Chris Magwo talk about the materials carbon emissions, and this is something that you guys are starting to focus in, and just talk about that particular subject and how that resonated with the clients and how that came about.
Yes. Alex, I'm going to pull up a slide if you want to.
Yeah. So actually, this is a really interesting subject, because for us, it was too, like, we came from the philosophy that, hey, if we make our buildings Passivhaus or like ultra efficient, it doesn't really matter. Embodied carbon doesn't matter, because we're going to be always pulling that back out over the life of the building. And then all of a sudden we realized, well, what time frame are we talking about? 40 years, 30 years? Like, how long is it going to take? We wanted to be carbon neutral by 2030, right? So if we are like, if our effort, for these upgrades are exceeding that, what would that mean? So we actually had, this is from the amazing work that Olivia Bain did. She was an intern at Greenhammer at the time. We were asking that question, like, how much more actually goes into our buildings compared to code buildings? And what we realized is that actually, you can see we have 3 bars. So we compared it to code building at the time, 2017, and our zero energy. And in between, it's Earth Advantage is a local certifier who says, like, they have like a builder pack. They're saying, like, if you do these measures, you're 20% better. And so we try to compare operational versus embodied carbon. And what's the result was really amazing. We're carbon positive, or we're basically making up all the additional embodied carbon to get to zero energy after the first year, right? You can see the top graph shows how we have more embodied carbon in the construction, but then down below, this is basically carbon emissions over the lifetime of the building, and you can see the zero energy building is like at 50% of the to code building over the life of the building, this is tally, I think 60 years is what they consider that. So we were really excited to realize, okay, obviously we do all the things that make sense to reduce embodied carbon with like bio-based, like FSC wood, bio-based insulation, as much as we can. In addition, actually, or as the big takeaway for us was concrete, right? Concrete is still one of the biggest impacts that we have. And so we actually talked to a local supplier. If you want to switch to the next slide, Laura, that'd be awesome. We actually have a local supplier who focuses on low carbon concrete, and we work with them. As you can see, they were actually able to reduce the embodied carbon of their concrete by almost 50%. They're really interested in this, actually, to the degree that they're actually buying offsets now, that they're really consider their concrete carbon neutral. It's a really interesting subject, because it's actually not that difficult to do, in the sense that the product isn't super different, right? So the cost is identical. They sell their standard mixed designs for the same cost as like these low carbon, which is really, just for people who are not familiar with that, the big one is really cement is the big story here. And so they're replacing cement with supplemental cementitious material, with a slag in our case, could be fly ash. And then in addition, they're using type 1L cement, which is not 100% cement. There's a little bit of limestone in there. So that's how they'll be able to, knock off 50% of the carbon in the concrete. And that was really interesting. That was new to me, like what's possible. There's a story here to, lessons learned, which is like your installer, like your concrete applicator, how they feel about this, what their working relationships are. We actually had to do some test pours, with our concrete folks, because they're like, well, I don't know how, like I've been doing this for 30 years. I know exactly how my concrete behaves. You're giving me some new stuff. I don't know if I like it. Let's try it out. And we did. And there's a few things you have to keep in mind, but they're really not tricky. And this is what we do now. So all our concrete is now 50% less embodied carbon than it was before. And it's really not a big change.
And just on the concrete part, because did you guys have to re-pour the slab, or did you just have to re-pour portions where you had to put in new
no, so this is no, this is not specific to this project, right? Okay. So we actually saved the concrete because you're saying like, hey, let's hang on to the concrete.
Yeah.
It's just like this whole embodied carbon present, like topic really made us think about like, how do we address this in general? So, you know, obviously not using it is best to begin with, right? So keep it if you have it, if you can. But then if you do have to replace things, keep these measures in mind, and then actually you will not run out of your 2030 timeframe. We will be making up this with operational energy, whatever we need to do to the building to get, you know, as efficient as we can, which is the big takeaway for us to say like, okay, we're on the right track to if it's the right embodied carbon, you know, additional insulation and so forth, it may, you know, you can make that up by operational savings.
Just to clarify, because I don't think I ever did, there was a little bit of concrete that we did pour for the exterior bathroom, and there was a portion that was exterior to the original enclosure that we then enclosed. It had roof over it, but we poured concrete there to give it a real foundation.
Pretty minor compared to what you got to start with.
Yeah, maybe 5 to 10% of the footprint.
Gotcha. Scott had a question. I'm just going to ask you this quick one because he's local to you guys. Who's your concrete supplier?
Worked with
Wilson Will Concrete. Yeah.
But there were a couple others, right, Alex, that we found that were also willing and able to do low carbon mixes.
Well, so it's interesting. It's like so our big suppliers, this is really a struggle. Wilson Will is like, I think they're around for 3rd generation, but they're a small supplier, and that's really their niche. And so a lot of concrete installers have like these relationships with the bigger companies, which honestly, like we talked to some other ones, Carl Portland being the biggest one, they do have low carbon concrete mixes in their portfolio, but it's more difficult to get to that point. So what I definitely recommend is if you have concrete coming up, get a hold of the mix design and then call the people in the plant and say like, hey, do we have an equivalent with like more fly ash or slag in it that would reduce the carbon footprint? And I'm pretty sure that they're going to have something that they can offer that probably is going to be in the 20 to 30% reduction. So definitely asking the question, whoever the supplier is always important because there's probably something there that could work.
No, great. And I had an interesting lunch today, and I was talking to somebody about concrete, and it sounds like the concrete industry is we've pinged them enough that they're aware of this. They know how to fix this. They have zero interest in fixing it until the market starts. So all of us keep pinging the concrete people to fix things. I know the Carbon Leadership Forum is doing enough to, you know, get into their regular Monday morning news to let them know we're coming and we're demanding this. So all of us just either get rid of your concrete and do other things, or keep planning ahead. So, sorry, Laura, you raised your hand, so I'll go back to you.
I was simply agreeing.
Yeah. Okay. No. And again, like all these kinds of things, we had a good discussion last night about materials. Again, we're aware of these things, and now that we're aware, we can start demanding and asking for change, and really move things forward. And I think, even in the last 3 years of understanding what Chris has been involved in, Anthony Pack with the local Carbon Leadership Forum here in Vancouver, this stuff's on our radar. We know about it, and we need to just figure out how to get into the discussion and ideally be able to keep planning better some more, because if we have time, we can make these changes. It's just a question of understanding what the changes. And so, Alex, just a question too is, did the concrete installers just have, like, is the material just thicker, so they're going to deal with handling it more, or what were just highlight some of those issues that they raised?
Okay, so the big again, like, I'm not as proficient with concrete installation as I would love to be. I come from the wood section as well, but it's essentially, it's all about the bleed water, because you have less cement, you see less bleed water, so you think it's further along in the curing process than you used to. And so as you finish, particularly if it's exposed concrete like slabs, if you finish it you have to relearn, like, to get the cues from the concrete, right? So that's really the big one, which I think it seems straightforward once you know it. There's like inhibitors you can put on there, so you have less evaporation. So once you know these things, it doesn't seem to take any longer. It's not going to be physically any harder. It's just there's things you need to know and the experience you need to have. And at that point, it's like, again, same cost. Otherwise, similar behavior. What's going to come up a lot is like initial strengths, right? So, which I didn't point out on the graph, the 28 day strengths is the prescribed strengths, right? 3,000 psi. It's actually going to be higher in the longer it's cured, like higher than conventional concrete. But the initial strength takes a little longer. So that's the one thing that if you have, as we all like stressed for time and they want to strip their forms the next day, it depends what that pour is. They might not be able to strip their forms the next day. They might have to wait another day. So if that could be an issue, but I think it's minor and it might be an opportunity to work around. And again, it depends on what you have, and you can still talk to your concrete supplier. They know these issues and they can help you out, like dialing in the mix design for your, for your situation.
And that's a good point, because even if you did have a timing issue, they just add more inhibitors, but it's really getting the cement part out of that, or the concrete part of the cement. So great insight. Well, I believe that is the list of my questions. I know I had a couple more, but I'll just leave it open if anyone else wanted to jump in while I kind of scroll back up to my notes here. Laura, Alex, thanks for leaving the contact. Oh, go ahead, Mary. Yeah.
So Alex, I missed the very beginning, so maybe you talked about this, but what were the trade-offs? Because, you did so much and you got a great ACH. What were the trade-offs that you didn't do that would have allowed you to be certified? Like, what were the compromises that you had to make for your budget, to meet your budget?
Well, so, the certification cost, modeling cost. So we kind of did like a preliminary model, but we basically said like, look, we're not going to model anymore. Certification costs. And then the big one is really the airtightness, where I said like, look, we're not guaranteeing a goal. We're going to do the best we can. But those are the big ones, right? So we never actually did the analysis like how close are we to Passivhaus certification. It's also like right at the level where we're, standards changed a little, and now we might be more likely to be able to meet than at the time. But it really felt like, look, we want to streamline the components we can install, and just forgo that, because it felt like if we guarantee Passivhaus certification and then we have a hiccup, that would have they could have derailed the project for us. So. It's probably nothing new that you know.
Okay, so there wasn't like, oh, well, we didn't do X because we just couldn't afford it.
Well, besides the air barrier, probably not. I mean, we had like concerns around the existing slab and, insulation of the slab. Mm-hmm. It's unclear whether, we could probably have walked around it, but at the time it felt like this is the most streamlined process we could offer. In that regard, and that's what we focused on.
And the other question I had was about the deconstruction process. It just it's great that you guys have a company that will do that, but I just wanted to hear a little more detail about it. So when the materials get taken off your site, is there just like a giant warehouse that then other people can walk through, and how do you feel about other people getting like crappy windows or stuff, or like, the materials that are being hauled off? What, can you just talk a little bit more about that whole process? Wait, you're muted.
Alex, do you want to kick off then?
Sure. Well, I mean, I'm like none of the performance related, like for example, inefficient water fixtures are not going to get reused. Windows don't get reused. It's probably, I say the bulk is the wood products, right? Wood flooring, wood siding. We still have the challenge around lead, obviously, with existing siding. What we can say, I probably should understand the numbers better. So like Lovett Deconstruction, they've been in the business for a long time, and we work with them on all of our projects. It's actually, even before deconstruction, we do another round where we do donations, right? So we have like the Restore and Habitat for Humanity and the Rebuilding Centers, the local organizations where we say like, okay, what are you taking? And so first we're going to give everything that makes sense to them to you. so that it's reused. And then Duralaba does the deconstruction, and again, like denail everything. So all the wood products are recycled. Would be, like I said, would be great to understand like what the percentage is. All I can say is that there is really a thoughtful process in this. So it's not just around maximizing profits with recovered material. It's really about like what makes sense. And yeah, I think that's probably the best answer that we can have on this one.
Yeah, I think that also dovetails nicely with doing renovations in general, where the client or the inhabitants might still be near or on site, right? Like we didn't have a big bulldozer come in. In fact, we're not even allowed to in Portland anymore, like completely demolish a building. But because it was done carefully, the kids were literally 10 feet away from the construction fence at all times playing outside, and there were no issues. Also, Lovett Construction has a big warehouse where they keep a lot of wood that they find and love from projects and then reuse it on other projects. So they have their own circular economy.
Great, thanks.
Yeah.
And interesting enough, Mark Willey is going to have Unbuilders on his show on BS Friday. So if you wanted to learn about a local Vancouver company that is now expanding into Victoria and other areas, and they're so they do the same thing where they have Habitat for Humanity and a Restore that they offer rebates, and a lot of the initial stuff goes to them. And then they have another company called the Heritage Lumber, which now sells. And interesting enough, a lot of those crappy windows, especially the lovely wood ones, went into a lot of restaurants for dividers during COVID, because it was a cheap, easy way to make sure you got your dividers. And most of them now are still there. So a lot of that amazing wood ends up being, or those things get used up. And it's interesting enough. And actually, this latest project that I saw, which has these amazing 100-year windows where the lead bowed, because of that's what lead glass does, they're going to add that into a feature into the new home just because it's a cool heritage piece. So it's great to see that people are being able to have these story pieces come back into the new homes because they appreciate all this 100-year-old wood and all the benefits of it. So
there's one more story similar to this, actually, that might be worth mentioning. We actually have an emerging new business, Valerie. She's actually she's literally dumpster diving and pulls out like basically virgin lumber out of new construction sites, packages them up and resells them to us. And it's amazing. I was thinking like, is this all shorts? She said, no, you'd be surprised. We like pull out 10 footers, 12 footers out of the dumpster, like, so they can supply full lumber packages with basically reclaimed lumber. And so we're doing, obviously most of it is short, and we're really dialing in our process with them for like blocking and shorts and things like that. But it's such an innovative idea, and we're working with the local sustainable lumber yard to basically start like, okay, we fill your order with the reclaimed lumber first, and then the rest we fill in with our FSC lumber, right? So we're maximizing, we have a guarantee that we get what we need, and we're maximizing reclaimed before then sustainably harvest. So these are the kind of stories I think that are awesome, and it takes a little bit more coordination and willingness, right? So we have we have a little show and tell with our framers who are like, hey, yes, there might have been a nail in there or there's paint on it, but it's perfect lumber. And there's like, once they get the story, they're like, awesome, this is what I want to do. I get it. Let's do this. That's just a great story. Yeah.
Yeah. No, great. Those are the ones we like to share. So thanks for all that. Mary, great questions. But even too, with the blow order test that you guys got in the end, it was below 1. So you guys, tick that box for retrofits. So that's a nice gem that, you didn't plan for, but you did. And so that ticks off the certification. And I'm wondering, now that you've finished and you were like, oh, we didn't have the money to do the modeling. Now, could you get a grant to say, hey, could we get some money to then see how close it was? Like, is there, I don't know, I was trying to see if Zach was around. Like, Zach, find them a grant so they could go and verify, because I know they're close. Like, now that you've done this, you're close. It's just a question of having the resources to get somebody to go for a day or a couple of days and finish the PHP to just see how close it is, given that it couldn't fit in the original budget. But now you've got the end result. We're like, well, pretty close. Like, you hit their tightness goal. What's the heating and cooling demand goals? Because I'm sure you're close. So
I like that idea. I would love to see the grants first and foremost going to other preschools to make these kind of projects happen across the board,
Absolutely.
across the world, just because,
Yeah.
oh my gosh, these kids in there are totally, they've drunk the Kool-Aid already.
Well, again, the fact that you taught them construction, the fact they're around it, then they see the benefits of it. Like, I mean, the photos look amazing. Again, I can't wait until I can come back to Portland so we can have open house days, because I would sign up for sure to see that one, and because it's fantastic.
Yeah.
But again, I mean, getting our kids involved in this, they get it now, and so having the Kool-Aid that young can't change. So they're future Green Hammer design build employees. So good on you. All right, Zach, that's all the questions I see in the chat. Laura and Alex, can't thank you enough. Appreciate all you do, and great slide deck, great presentations, just a beautiful project. Can't say enough about it. And again, you've made the planet better, and hopefully you've done more, and hopefully you taught Mark how to do it in Pennsylvania, and we can continue doing this. So appreciate all this great stuff. Thank you, everybody. Awesome community you've created.
Thanks, Laura. Thanks, Alex. Really, really
Thanks
fantastic.
for having us.
Yeah.